yesterday we were looking at, remember, a definite integral. What is a definite integral? What makes this a definite integral? It has the upper and lower bounds, right? The two numbers here. All right. So, and what does the definite integral tell you? The sum of, because the integral sign means sum, of all the rectangles between -2 and 1 for whatever function we're dealing with, right? So it tells you the area under the curve, okay? So there's some properties. And remember that the area is essentially this. It's a limit, right? So the limit properties apply to these integrals. Okay, just like the limit properties apply to the derivatives because they were limits. So here we go. If we are integrating something what's the answer? Okay, what does the definite integral represent? It's a to a, and it represents the area. So what is the answer here? It's 0. Yeah, is that what you're trying to say? It's 0, right? You're representing the area of a function. Whoops. It doesn't matter what the function is. If I call that a, what's the area? Not 1, it's 0, right? Because there's like, a is just a number. It doesn't have a width or anything, right? So there's no width to the rectangle, so it's 0. All right. So I've reversed the upper and lower bounds here. The lower bound, the number on the bottom should be smaller than the number up top. So if I want to flip them, you can literally flip them, but you have to write a negative sign in front. Okay? So you can flip the bound as long as you throw a negative in front of the integral. Okay? If I have, let me draw a graph over here. Doesn't matter what the function is. A to B I have value C. Doesn't matter where C is, somewhere in the graph. Doesn't have to be in the middle exactly. Then remember this is f of x. So the area between A and B of the function, which is this shaded region here, will be equal to the area from A to C dx plus the area from C to B of the function. In other words, you can split it up. Like I can divide it and add this area, which is this bit, and then add this area, which is that bit. And you'll see sometimes, especially if you do Math 101, that's advantageous, okay? Depending on what's on your graph. Number 4, if you have an integral, k is a constant. What can you do with constants and limits? You pull them out, right? Just like in derivatives. So I can pull constants outside of integrals. Again, that's a good thing because it's simple. It can simplify your calculations. So constants can come inside and outside of the limit, or the integral. And the final one, these are all the same as the limit ones, if you've noticed. If we have two functions that are being added together inside of an integral, you can evaluate each one of those functions separately and then add or subtract their answers together. G. And I forgot the dx here. So what that means, just a quick example would be if you're evaluating some function like a quadratic like this, I can just rewrite that as this one plus this one plus 1 dx, like that. Okay, as long as it's addition or subtraction, not if it's multiplication though. Okay. You have to multiply it out, and yeah, like if you had integral of, make it easy, x plus 1, x minus 1, like this, from a to b, I would literally just multiply those together, get x squared minus 1, and then you could break it apart if you wanted to. Yeah, because now it's turned into a sum, right? This you can't break it into the integral of this times the integral of that. You can't do that. You can only do it if it's an addition or subtraction. Okay? Okay. Page 273. These are all just doing properties. I think I already gave you these. Did I give you these questions yesterday? 13 to 27 odd. Did I give you those ones yesterday? 13 to 31. Okay, so then we're going to do 41, 47, 61, and 62. Please. And that's it for today. What happened with division? You would simplify inside. Again, division and multiplication are essentially the same thing. So you'd have to divide them out. We'll look at those because there's ways to rewrite them. Like you can do polynomial division and rewrite them a certain way, and it makes your life easier. So, okay. But we're right at the beginning. So on